All right, this is problem 1B on the worksheet. In 1A, we figured out the maximum velocity of a mass spring system. In 1B, it says, find the velocity at 6.2 centimeters. The amplitude we know is 10 centimeters. The period is 0.20 seconds. And it says, find the velocity at 6.2 centimeters. So it's begun to move from the amplitude towards equilibrium, but it hasn't even moved halfway yet. Okay, so it's not even halfway to equilibrium. So a couple of things we need to do. First, we need to know the equation. You should have that toolbox of equations that we worked on in class that you set aside, and make sure you have that when you sit down and try to take a test Friday, Monday of next week. Our equation for the velocity at any point along the path is plus or minus, because it could be going either way. The square root of k over m, k is the spring constant, m is the actual mass, times the square root, or times the product of quantity a squared minus s squared. All right. Now that's one version of the equation. We don't know k or m, so we're not going to be able to use that version of the equation. But remember, there is another version. V equals plus or minus 2 pi f times the square root of a squared minus s squared. That's the second version of the equation. So make sure you have both versions, because it depends on what you know. If you know k and m, you use this equation. If you know the frequency, you use this equation. Now, some of you are saying, well, Mr. Morgan, we don't know the frequency. You do know the period. You know that frequency is equal to the reciprocal of the period. So that's going to be 1 over 0.20. And if you get out your calculator, mine is over there. 1 divided by 0.2 equals 5. 5 hertz is the frequency. Now we know the frequency. We know A and we know S. Now, one more little thing you have to worry about before you just willy-nilly plug things into the equation. A and S are distance measurements. It's the amplitude, how far you initially stretch it from equilibrium, and S is where it currently is now, how far it is from equilibrium now. We have them in centimeters. That's not good. We need them in meters. So A is actually 0.10 meters, and S is actually 0.062 meters. So those are the numbers we're going to plug in to our equation. So let's do that. V equals plus or minus 2 pi times 5 times the square root of a squared, 0.10 squared, minus s squared, 0.062 squared. And when we do that math, I'll go ahead and do it right here. You can do it yourself. 0.1 squared minus 0.062 squared equals, I get 0.006156. I want to take the square root of that. I get 0.078, blah, 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 blah. Then I go times 2 times 5 times 3.14, and I get 2.46. Of course, plus or minus, and of course, meters per second. Now, one final thing you might want to do, does that make sense? Does that answer make sense? Compare it to the answer you got in part A, which was the maximum velocity, and that was 3.14. So 3.14 is the maximum. This is less than the maximum. That is a reasonable answer. All right. Thank you.